Hello students, you are watching my channel Maths with SK Sharma and I am SK Sharma. Today I am going to discuss class 10 first chapter problem which is there in the last exercise of your book. Now what is the problem? What concept we are going to discuss? Without actual performing the long division to tell whether given rational number have terminating decimal expansion or non-terminating decimal expansion. Terminating decimal expansion or non-terminating decimal expansion. This is the problem we are going to discuss. Theoretically, you must find it in your book. In a rational number p upon q, where p and q are integers, q is not equal to 0, and also you should note that p and q are co-prime in a rational number. Where p and q are not co-prime in a rational number, such rational numbers are called equivalent rational numbers. So actually there is no common factor between numerator and denominator of a rational number. Q should not be equal to 0, p and q belongs to the set of integers. These are the conditions of a rational number. So if such rational number is given to us where p and q are co-primes, then what are the conditions by which we come to know that whether its decimal expansion will be terminating decimal expansion or non-terminating decimal expansion, that we are going to discuss. So if prime factors of q are 2 raised to the power n into 5 raised to the power m, where n and m belongs to the set of whole numbers, we get terminating decimal expansion. This is the first condition for terminating decimal expansions. Similarly, if prime factors of q are not in the form of 2 raised to the power n into 5 raised to the power m, we get non-terminating decimal expansion on actual division of such rational number. Now let us understand these things. 2 raised to the power n into 5 raised to the power m. These factors, these prime factors, how we will negotiate, how we will get these prime factors. Let us do it with the help of examples. Now I am taking one example, 17 upon 8. When you will do the prime factorization of 8, you will get 17 upon 2 raised to the power 3. Now you will say, I have only 2 as factor, where is 5? So 5 is there. How? 17 upon 2 raised to the power 3 into 5 raised to the power 0, you can say. So it is in the form of 2 raised to the power n into 5 raised to the power m. So you will say that 17 upon 8 will give you terminating decimal expansion. Similarly, let us take one more example, 31 upon 3125. You will get 31 upon 5 raised to the power 5. Here, these are the prime factors of 3125. So you can write it as 31 upon 5 raised to the power 5 into 2 raised to the power 0. So again you can say that 5 is there, 2 is there as prime factor, but there is no other factor. So it is in the form of 2 raised to the power n into 5 raised to the power m. So you will get once again terminating decimal expansion. Now let us take one more example. This is 15 upon 600. Now you know what I have told you little earlier. 15 upon 1600. This is not actually a rational number. It is equivalent rational number, equivalent to 3 upon 320. So you should cancel, write it into the standard form. You will get 3 upon 320, and then it is 3 upon 2 raised to the power 6 into 5 raised to the power 1. So it is 3 upon 2 raised to the power n into 5 raised to the power m. This 2 raised to the 6 into 5 raised to the 1 is in this form. Once again 2 raised to the power n into 5 raised to the power m. So once again you will get terminating decimal expansion. Now if you will see this 64 upon 455, you will get 64 upon 5 into 7 into 13 as its prime factors. Now here you have 5 only, and two other factors, 7 and 13. 5 only you can say. Also you can say 2 raised to the power 0 into 5 raised to the power 1. So on one hand you can say that you have 5 as its factor, and actually it is 5 as one prime factor, but 2 is also there. If you write 2 raised to the power 0, and you can write 2 raised to the power 0, because what I have told you, that n and m belongs to the set of whole numbers. So 2 raised to the power 0 you can write. So it is 2 raised to the power 0 into 5 into 7 into 13. So what is the condition here? That 2 and 5 are present. You can say 2 and 5 are present here in the denominator as prime factors, but two other factors are also present. So when some other factors are also present with 2 and 5, you get non-terminating repeating decimal expansion. This is the point to be noted. Again, 29 upon 343. Now do the prime factorization of the denominator. You will get 29 upon 7 raised to the power 3. Once again you can see here directly, you can see here that there is no 5, no 2 as its factor. But once again you can write 2 raised to the power 0 into 5 raised to the power 0 for your understanding. But some other factor 7 is also there. So it is not only in the form of 2 raised to the power n into 5 raised to the power m, but also having one more factor. And if you are having 2 and 5 as prime factors and some other factor is also there except 2 and 5, then you will get non-terminating repeating decimal. So what is the conclusion in shortcut? In short, you can see that if p upon q is a rational number, means p is numerator, d is denominator, and you do the prime factorization of the denominator, you will get 2 raised to the power n or 5 raised to the power m, or both will be there, 2 raised to the power n into 5 raised to the power m, and all these cases will give you terminating decimal. It means if in the denominator you are having only 2 raised to the power something, you will get terminating decimal expansion of that rational number. If you are having 5 raised to the power m, 5 raised to the power something as denominator, then again you will get terminating decimal, and if both 2 and 5 will be there, you will get terminating decimal expansion for that rational number. And if in this rational number, in out of these two, numerator and denominator, while you do the prime factorization of the denominator, if that prime factorization of denominator will give you 2 raised to the power something into some other factor except 5, then you will get non-terminating repeating decimal. Means 5 can be there is no problem if it is 2 raised to the power something and 5 raised to the power something, but some other factors should be there, as it is 7 and 13 there. So if with 2 some other factor, or with 5 some other factor, or with both 2 and 5 some other factor is there, you will get non-terminating repeating decimal. So these are the condition, and this is the technique to find out whether the given rational number will give you terminating decimal expansion or non-terminating repeating decimal expansion. If you uh, like this video, then push the button of like also, and subscribe my channel for more videos. Thank you very much.